Hi, I'm Jeff Bryant.
I'm Eila Stiegler. I'm the manager of quality analysis at Wolfram Research.
And I'm a research programmer at Wolfram Research, and we're going to be giving a talk about the Champaign 2017 Marathon.
We're going to talk about the sponsorship that Wolfram Research did for the local Illinois Marathon. I'm going to give some background of the whole story, and then Jeff is going to dive into the more technical aspects and all the coding that had to go into this project. So, running at Wolfram, I love to run. I do it a lot. It's the only thing I've ever really loved to do, and there are quite a few people here at the company who do it as well. So many of us like to run. You can find us everywhere all the time out on the roads. Especially the Champaign crowd is fairly robust. Not only do we have a complete lack of entertaining scenery, but we also fight the elements all the time. Whatever the weather, it's not good. So whatever it is, there's too much of it. We have too much sun, snow, humidity, you name it, we fight it. So we give kudos. You can find us on Runkeeper, Strava. We have a Wolfram running group there, and an internal mailing list as well at the company where we exchange information. So if you find your picture here, you have something to do with running. I found you somewhere in this orbit. So why do I like to run? Health, of course, is always a good reason, but when I go out on the street, I'm really not concerned about my expiration date, and considering how often you almost get hit by a car, it really seems counterproductive. It does help me maintain some level of sanity, or the appearance thereof. It's location independent. I love it. If I go travel, I pack an extra pair of running shoes, out the door you go. It's amazing. And my favorite reason, runners are a really friendly bunch of people. When you're out, people greet each other, they chat, they have stories. You can hate on the weather together. It's great. And if you've ever participated in the race, you will see the spectator signs. They're to die for. They're really hilarious, often politically incorrect, and R-rated. So there are a few examples. These are not necessarily from Champaign, but you see them, in all the cities are alike. There are some pretty good ones. So to give some background, as I said, I've always run, but I didn't get into longer distances until 2014. I have done 8 marathons since then, and one of them was the Bank of America Chicago Marathon in 2015. I really liked it. After I got done, I come back to work. We sit down and talk about the event and the fact that close to 40,000 participants were at this event, which makes for a fabulous data set. There's nothing we like more at Wolfram than a big data set we can play around with. So we nabbed the data, we turned it into an entity store, and then in 2016, I wrote a blog post about my experience in Chicago. And so we didn't just look at an individual runner, it's really the field of runners, where everyone comes from, what does the group of the 4-hour runners look like, which people ran together, or if you travel thousands of miles and you have this giant expenditure on a marathon, do you come from a country that has a high GDP? Does this relate? Do you have deep pockets? All of those assumptions were incorrect, by the way. So after we published the blog post, we then took up a conversation with the local race administration, and they really liked the idea here in Champaign to work with us. They really liked having a software company as a sponsor, and if you consider it's not a big event, it's not Boston, it's not New York, they always look for something that sets them apart from other big races, and so they were all for it. So why is the sponsorship good for us? Well, it is a really good event to be part of. It ties together both communities. The little spiky shows our location at Wolfram Research. And the runners, like for the marathon, you start outside State Farm Center. And on your way, you cross campus. You go through both downtown areas, all major like a lot of residential neighborhoods, park features, really anything that's relevant in this town. And the kicker, of course, is that you get to finish inside Memorial Stadium, which is just amazing. It's a really nice thing to go through. You know, you come in, you have the speakers, you have the music, you have the crowds in the stands, and it's really amazing. The event itself has become quite relevant for the community. So it was first held in 2009. The number of runners since then has doubled, basically. It started with 5 events on just one day. It has grown into 9 events over 2 days. It's a Friday night and a Saturday. We have a lot more volunteers, many more sponsors, hotel partners, and the economic impact is, it's quite a bit. This is all, the runners coming in and solidly booking all available hotel rooms for the weekend, spending money locally, going out, and also the charitable giving has reached $1 million. So this year alone, I think it was $130,000, which is it's a really good event to be part of. So then we have some random numbers, and Wolfram Alpha has something to tell you for all of them, which is great. So taking the 9 events from 2017, we covered 198,025 miles, which is comparable to 0.83 times the mean moon-Earth distance, or 3 million soccer fields. Food, not yet. So marathon literally would not happen had Walter Hunt not invented the safety pin back in 1849. So we need 80,000 of them for one such marathon. Now the food. Runners gobbled through 1,600 oranges, 15,000 bananas, 9,600 gallons of water, and almost 2,000 gallons of Gatorade, and that's just along the race course. The sugar in those oranges, 20 kilograms, is staggering, but I will tell you, an orange slice at mile 20, when you start to question your life choices, will fix everything. And also, Wolfram Alpha can tell you that we can fill 2 bathtubs with those oranges. So then it's just obscene then at the finish line. We eat another 800 pounds of pasta, 1,100 pizza, and go through almost 33,000 bottles of water. The calorie count in the pasta and pizza is 1.8 million, which, again, quite staggering. But that's not where it stopped. This year, the theme of the marathon was the 150th birthday of the U of I. So naturally, the race administration decides to order 70 sheet cakes by the dimensions of 18 times 24 inches. So we called the Maya Bakery to find out that one of those cakes has more than 21,000 calories, which makes another 1.5 million, which then again is actually comparable to the 15,000 bananas I mentioned before, which makes for an interesting conversation with your child if you take the, base sheet cake unit of 2 by 2 inches, whether to sheet cake or to banana. Also, Wolfram Alpha can tell you that the sheet cakes make up 150 times the calories that Michael Phelps takes in during his Olympic training days, or it's 2 years of food intake for a single person. So what to do with those calories? Now you've run a marathon. Wolfram Alpha can tell you with those default values of, your male close to 160 pounds. You run the marathon distance at a 9-minute mile pace. You burn a little over 3,000 calories, which it'll take about 500 marathons to burn off just the sheet cake calories. But guilt-free, after marathon, you get a free beer. So if we take this into account, just to replenish the calories you burn through a marathon, you could, if you were capable, have 28 of those free beers, or back to the sheet cakes, 15 of those pieces. Did I mention weather? So weather is crucial in Champaign. It's just not a very forgiving place to run here. And it's always a problem for the race administration. So if we just look at 2016 and use some weather data, the rain basically waited for the event to happen. It moved in, it unleashed, and it just stayed for the length of the marathon. So by the time I crossed the starting line, I was drenched. There was not a dry minute through this entire event. And if you look, we start at 7 a.m. and people are on the course for 6, 7.5 hours, and they got all of it. Interestingly, this is not the low point for Champaign. The low point for Champaign is 2015, when we get a thunderstorm, and not even as much rain as 2016, but the thunderstorm created so much lightning that was really close to the race course, and we had a lot of lightning hit the ground in too close proximity that during the race, at some point, the administration had to cancel mid-race. This doesn't happen often. Marathons do get canceled, but not mid-race, while you have thousands of people on the course. So that was an administrative nightmare. I will admit, I was at mile 18. The cops come by. They tell us it's canceled. I'm like, thank God. I had the worst race. And I was not one of the people that just was dedicated enough to finish. I bailed. Like, I was gone. But I did keep the News Gazette from that weekend because it was just such a horrible weekend. But yeah, so that's the background. And so now over the summer, 2017, we got the data set from the 2017 race from Champaign, and I'm going to hand over to Jeff. He's going to talk about that.
Okay, can everyone hear me? Okay. All right. So, I am not a marathon runner, but I got to stay behind and process data. It's a Herculean task in its own right. Real-world data is extremely messy. I don't know how many of you out there actually have ever tried to actually clean up some kind of a CSV file, anything like that from the real world, and tried to make it computable. I know pretty much everybody in Wolfram Alpha knows all about this because we do that a lot. But there's a number of tools that are very useful for cleaning this up. Stephen actually had a blog a little while back, and there's a link to that in the talk here, where he has kind of a 10-step process for how to clean data to make it computable, and that's good tips to follow by. So the first thing we did was we had to import the CSV file. And you can see here from the header of the CSV file some of the properties that are provided in the data set that they give us. We've also looked at other marathons, not just Champaign, but we've looked at Philadelphia, Pittsburgh, we've done Houston. We've kind of done these as background things, and they all pretty much have basically the same properties. We have to tweak things a little bit on a per race basis. But the one thing in common is that they're all very messy. You have to do a lot of cleanup to make the data computable. One of the best tools that you need to use is Interpreter. The data comes in as a string, but if you want to compute with it, strings are kind of hard to compute with. But the Wolfram language has a lot of entities in them, and you want to convert a lot of these things into entities. Things like the city where the runner came from, their zip codes, their gender. These are all things that the Wolfram language has a representation of as an entity. And so how do you turn these strings into one of these entities and figure out what it is? Once you've done that, you can actually get access to things, properties in city data, the actual latitude, longitude of those cities, things that you can actually compute with, but you've got to align them first. And that's where Interpreter comes in. Let me scroll down a little here. So here's an example where from the CSV file, we're able to get their city, their state, and the country, put those together and string join them, and then you can call Interpreter City on it, and what you get back is the entity representation. So each one of these calls essentially goes through a Wolfram Alpha parser and then turns it into the internal representation. Now the problem is this can be messy, as I mentioned before, as all data can be. Here's an example of something that might fail. So you always have to have fallback plans. There's never just a this will always work for you. You usually have to make multiple passes to clean things up. So here's a case where somebody put in for their city Scott Air Force Base. It's not really a city. We've seen all kinds of weird things, especially in the city fields. People will put in their address. They don't actually put the city. They put an address in. They put an Air Force Base. They put a neighborhood. That's a subtle differentiation. They might say Queens rather than New York. But from a an alignment point of view, it's actually it's a difference. So these can all throw off an attempt to align these things. So often what we were able to do here was we were able to fall back to their zip code in the event we couldn't figure out what city they were from. And postal code is provided, so you're able to do that. And then we can call geo-nearest on the resulting city to determine what they are. And it turns out we actually did have Scott Air Force Base right there, and we were actually able to get the alignment. Sometimes these misalignments are because the thing they provided aren't a city. Sometimes it's because they misspelled it. Sometimes it's because we're lacking linguistics, and so these are sometimes cues for us to add linguistics to our stuff to pick some of these up. But they're all things, if you're trying to clean up the data, you've got to be prepared for. That's it. Okay. One of the biggest things, most of the data that you really get out there that you really care about are the split times. So the Champaign Marathon had several different splits. Of course, there's the start, then there's the 10K, the 10 mile, the half, the 20 mile, and the finish. Some of the other marathons actually have more splits than that. Champaign just has a little fewer. It's a smaller scale marathon. So, but they provide the split times as strings, just like everything else in the CSV file, and we want to turn these into quantities so that we can compute with them. And you have to be very careful. So, for example, here is an example where we take the string value, we do a string split on it to get rid of the colon, we convert those into numbers using from digits, and then we turn that into a quantity that's mixed magnitude, hours, minutes, seconds. Looks like we're all done. Not quite. You have to be very careful because the data set actually contains not just the full marathon runners, but it also contains people that ran, say, the 5K. And the problem is that the difference between those runners is how they reported the times. Sometimes they give you a string that looks like this. Notice the first number is 25 there. Now, if we always assumed that this was hours, minutes, seconds, that would be a really slow runner. So something was obviously wrong. And it turns out it's because they had actually done, for the 5K people, they had done minutes, seconds, milliseconds. So we had to actually put some logic in our thing as to what units we're supposed to use here. And at first we thought we were done. We looked back, it's like, wow, this is really weird results. And it turns out it's because of this issue. Once again, real world data is very messy. And then for assembling the data, as Eila mentioned before, we actually used an entity store. Has anybody here actually used an entity store? Actually tried creating one? They're fairly new. I think was it version 10 we added them? Yeah, so they're new as of version 10. They're essentially the user way of creating your own data packlet. So if you guys are familiar with the data packlets we had since version 6, and then starting in version 10 we had entity value, we have our own, those are still kind of data packlets just accessible through the entity value framework. You can now create your own. And the way you do that is essentially you set up, it's essentially like a list of rules, but it's done in association form. And you basically have your property labels followed by their values. And once you've got all these set up, this is an example, I guess you could say an entity and all of its properties for the marathon. And you can see we've already aligned this. Some of these things just stayed as strings, like the last name of a person. You know, there's not much you can do there. There's not going to be an entity for every last name possible. But first name's Walter, things like that. But other things, like the city, we can align those with entities. The state, you can align those with entities. Country, zip codes. We've got the gender in there. We were able to align with an entity. A lot of these things are just numerical data, so you leave those leave those as they are. But then you get down to the splits, and you can see for each one we were able to construct the net time as a quantity, the time of day, and then the pace. Now the pace doesn't really make sense until you get down to the first split after the start, but then you start getting how many minutes per mile the person ran. So once you do that for all of the rows in the CSV file, before I talk about how to assemble those, we actually had two sets within our entity store. One was the list of runners, and the other was the list of divisions. So you have various divisions within the data set where you had, here's a list of all the ones that the Champaign Marathon included. For example, male 20 to 24. This is their age ranges. So typically the divisions were broken up by sex and then also by age, with a few others down there at the end. And then for each division, you had different properties like the mean, net time, things like that. And then the list of properties for a given division, you can see right there. Let's see, I'll speed up here a little bit. I'm running out of time. And then the last step after you get those is you actually assemble the entity store, and that's basically just a wrapper with metadata. You basically take those lists, those associations, and those would go in these positions right here where you say, here's the entities. You specify what the properties are and the labels, the yellow boxes that show up. Those are the labels. And that's it. When you're done, you just write it out and you've got an entity store. You're ready to register it and you're ready to compute with it. And then this is a link from Steven's talk, actually. This is his 10-step process for cleaning up data. He's got a whole blog entry on this that he's quite proud of, but it's a very nice chart here that kind of shows if you can get, like I think he mentioned, if you can get to 5, you're in pretty good shape, but you can go all the way down to 10 and just have really nice computable data. So I'll let you guys read through that on your own time. I think we've got a few more things we want to show here before the end, so I think that's my last slide, I think. Just verify. Mm-hmm. Yep, okay, so I'm going to switch back to Eila.
All right, so the question now is, what did we actually produce for Champagne for 2017? It hasn't launched yet, it's work in progress. Design is still gonna work some magic on it, but I can show you a couple things. And let's go here first. So we, you at the very top. So what we did is we're generating a movie. There's the winners, you can see them down here, male and female winner, median, and the center of gravity are pre-generated. You can then specify a bib number, your bib number, or if you want to compare yourself to other people, and we will add a dot for you in this movie. And so let's see when it starts running. So the purple wave shows how the field of runners is, passing along the race course. The height of each purple bar indicates, a certain number of runners per, I think the base was 0.5 kilometer. And it's nice because you can see in the beginning, we're all very concentrated. There's a wave start, but everyone's on the course within, I think, 30 minutes. But then, the first runners are off the field incredibly fast. The last runners, they take, as I said, the first runners are like 2 hours and some minutes. The latest runners, I think they take up 7.5 hours. So the curve flattens out because we're stretching along the course. And I always said, this is, if you're a traveling spectator, this is a really good way for you to watch and decide, where am I going to put my folding chair? When are the masses coming by my neighborhood? And so what we did in addition to this movie, because we've had something similar for the blog post, we can now tell you so Nicole Anderson, I made sure not to have a Wolfram runner as an example here. So we tell you your placement, which is something you get from the regular race results anyway. But we can tell you there were 2 people with the same first name. You were the fastest, if you were. There were 6 people with the same last name, Anderson, and you were faster than 3 of them. This lady, we can also tell her that she just barely missed her Boston qualifier by 1 minute and 35 seconds. So, less than 2 minutes over the course of a race, that's going to hurt a little bit. And then we can tell you for, the field of all runners, the red part of the pie is people that did not qualify, were not within a 30-minute range. The yellow is how many were within 30 minutes. Because I think if you're within 30 minutes of a Boston qualifier, you might want to plan and maybe adjust your training if this is on your to-do list. The green is all the people that did qualify. And then the same for the division. So that's the people that really you should be comparing yourself to. We give a histogram again for the different splits, and the red indicates where you are. So this is, when all the people pass through those splits. This lady did pretty well. So, and then this is also the performance over the course of the race, and that means at what percent or at what percentile of the field was she at those given splits. So she got a little, so she was always, within the 80% range of, which means so 100% is fastest. So she did really, really well. And then at the very end is a heat map. So for, where did all the runners come from? And the very last thing that I have to show, so of course we took 2017, we took the attendee list and ran it against the employee directory, and to make sure we get everyone who ran the marathon. And there were 4 of us, and I would say I'm the slowest, but here's the movie. So Rebecca, Larry, Yihei, and I'm in there. Rebecca's killing it. Yihei and Larry should clearly be training together because you were in the same spot for basically the entire race, and I'm just trailing. So, but that's it. Thank you.